Hello, everyone. Thank you for coming today. I know that there's a very popular speaker in the other hall, so thank you. You chose this track. So today we'll speak about microservices and how we test in them. You will see how we do it in Wix, actually our story. So if anyone here still don't know Wix, so we are actually a web-based platform that lets medium to small medium businesses to build a stunning website and manage their business in one place for free and without any programming skills. So to do that, we have 3 engineering locations, one of them here in Kiev. I'm from the Tel Aviv office, and I work at Wix over 3 years. And I'm a team leader of core services team. Actually, we are building infrastructure for the product teams. And we are taking care of cross-cutting concerns like authentication, authorization, emails, SMS, and etc. And an important part of my job is to make it easy for the product team developers to integrate with my services, because they do it a lot. And as you all know, integration is one of the hardest parts between teams in software development. So the agenda for today is to understand what's the difference when testing microservices versus the monolith. And we'll see different approaches, some better and some not so good, on how to approach this problem. So is it more challenging? What's the difference? So in the old world, we had our monolith. That's how we started in Wix. So all your code is here in this box. And you can just run it, and your test can execute all the code in just one run. Actually, it's not exactly like this. Maybe we have a database, right? So to test it with a database, we can run our database in an embedded version of the database, or maybe in a container. So we run our application, run the database, we can test it all in one go. Then, when the company grew and more users came, more developers came, we started to split this monolith to microservices. So we decided, okay, maybe authentication is a different concern of the core domain. So we created a service for that. Emails, maybe also some other service should take care of this. Billing, etc. And if it's not enough that now we have a lot of dependencies to our service, each and one of our dependencies have its own dependencies. So in the beginning, you start and it looks something nice like this. But after a while, when more developers come and they write more code, it looks like this. Okay, in Wix we have around 500 microservices today, and it's growing. And when you want to test this, like all your code now is spread around. You can't run this system, this whole system, and test it. So we need to find a solution on how to test our microservices separately. So we still want to have a short and reliable feedback loop. And we want to verify that our assumption versus reality. So if we assume that the service that we use behaves in some way, we want to make sure that this is happening in reality. We're talking about the logic and the protocol. So before we start, I want to do a short recap about what kind of test we are talking today, so everyone can follow easily. So for that, we created an example scenario that will follow with us all this talk. So it's a product flow. A user come to, like in this talk, let's assume we are building a store. This is our application. So a user come to the store with a session. The session includes just the user ID. The user make a purchase, and then the user gets a confirmation page. And his name should appear in the confirmation page. But the problem here that the data about the users is sitting on in a separate user server. So we need to find a solution how to test it together. The first type of test that we'll discuss today is end-to-end test, which are also called out-of-process component test. So, of course, in the reality, there our store have a database and maybe more services, but in this diagram, I try to put it to have the minimal stuff that we need for our example. So the orange line is the test boundaries. So in this case, we run our application in the end-to-end test, and the test simulates the user. So the test will log in, add item to the cart, make a purchase, and then look at the confirmation page and make sure that the name of the user is on the page. And of course, the blue box should be the user server there, but we can't run it because it's a different service. Okay, so that's one type of test that we're going to discuss today. The other type is integration test. Here we zoom in a little bit. So inside the store application, we have a module or a class that communicates with the outside service. For this talk, we'll call it user's client. And in that kind of test, and again, in the real architecture, you will see here like presentation layer and business logic and whatever, but I just removed it from here to make it more simple for the presentation. So in this kind of test, the test will communicate directly with this class, and then it in an isolated way without the whole application. So it will be easier for us to also test edge cases and abnormal behavior and all that kind of stuff. So let's see. We'll see now a few approaches, how to test, how we can do end-to-end test, integration test to our store application. So this is the naive approach. Just don't test it. But you probably don't want to go there, right? If you care about your application, you care about your product, you do want to have tests, to have a short feedback loop, to know about problems. Now, some developers find a way to go around this, and they think that they test, but not really. I want to show it to you, so everyone here aware about this approach as well. So this kind of test called in-process component test, and it means that we have another implementation of the user's client. We'll call it stub user's client. So we just avoid the problem. But what actually happens is that we have something like this in our code. And it might be something not like this. It might be like some fancy dependency injection stuff. But what happens in reality, the application is still aware of if it runs on production or in test. So what happens that our real implementation will be tested only in production. And we want to avoid this. So while this method is good, like the in-process component test is a valid method, but it can't come instead. It's good for other things like acceptance tests, but you do still want out-of-process component test. You want it because you want to avoid these embarrassing moments when you just do a small, tiny fix and deploy your application to production, and then it breaks. And why it breaks? Because a typo or maybe some wrong wiring, and then you fix it. So you put this commit, and then it still doesn't work. So you try to fix it again. So you have this commit, and then you give up, and you ask for somebody else's help. So please make sure you have proper end-to-end tests. So to sum this up, this approach fails on end-to-end, and on integration, it doesn't even deal with integration tests. Let's see another approach. Run against an external environment. Let's put it in our diagram again. So now we run against the real user server, but it runs on production, or maybe on staging, or somewhere else. while this approach has some benefits, like we do verify that the system behaves like we expect, like we assume it behaves, and it ensures the communication protocol and the schema. It fails on something else. It's unreliable, it has high maintenance cost, and adds complexity to your application. I'll explain why. First of all, our test run in the test environment, and then it calls to an external environment over the network, which might be flaky. So if it takes a while for your test to run, you don't want them to fail just because network flakiness. And then you need to rerun them. Also, like external environment, you can think about staging environment, about production environment, maybe some sandbox, one of these. So all of these environments have a setup because you need to pre-set up this environment. It also have state that shared between different teams that runs tests. So if my team run against this user server, another team, it can interfere each other. Also, it's adding complexity because if you use staging and you do some stuff like billing or SMS, you will have is staging flag in your code because you don't want to do the real billing, or let's say it's a user authentication, so you have a CAPTCHA. So for the test, you want to skip the CAPTCHA, right? Security consideration. Not always you can call, let's say you do RPC, so you can't call RPC to your data center. Also, what about non-happy use cases? So if I want to test what happens when the DB is down, I'm not going to shut down the DB in production, right? Staging, we had staging environment tweaks for a while, but now we don't have them anymore because it have a lot of maintenance cost, DevOps cost, and not always it's up. It's flaky. There are a lot of problems with that, and we don't do it anymore. So while in the beginning it might look like a good idea that it solves our problem of the external services, in reality, once you're working with this for a while, you understand that you should look for another solution. I want to note here that testing the run test against the production environment, it's something that should be done, but it's a completely different thing, not related to this talk. Because, for example, in Wix, we have an automation team that they run a suite of tests against production, but it's not like part of each team that tests it. We test the whole thing, and there are a lot of challenges, of course. And this is meant to test other things, like infrastructure and configuration, and not what we are testing here. So please try to avoid this approach, because it's not good enough for end-to-end, not good enough for integration. So try to avoid this. Let's try to improve it. The next improvement that we can do is to use test doubles. You can use fakes, smokes, stubs, spies. So our test will look like this. We'll have a fake user server, and the important thing here is that these test doubles will run behind some service that exposes the same protocol like the real service. So let's assume for this example that these arrows are all HTTP. It can be whatever protocol, but for the talk we can think about HTTP. So we'll put a fake that sits behind an HTTP server. So when we call it HTTP, and therefore we test the whole thing. So also, if the real user service is run on some heavy HTTP server, in test we can use some other lightweight HTTP server. It must be exactly the same implementation, but it should speak the same protocol and have the same schema. So let's look on a code sample, how our tests will look. So let's start with an end-to-end. So in this part, we set up our test. We generate a random user ID and some random name, and we set up the fake. In the next part, we log in as the user. We add some item to the cart, and we make a purchase. As a result of the purchase, we get the confirmation page. And now we can do the assertion. So we make sure that the confirmation page contains the name of the user. Okay, so actually this end-to-end makes sure that the system can start up properly, everything is wired correctly, everything runs, it can communicate with the outside. And in this kind of test, we run the exactly application that runs in production without any modification. So we know that if it will run here, it will run in production. So that's the whole test. Now let's have a look at the sample code of an integration test. Now to remind you, we are just testing the user's client class. So again, we set up in a similar way. Tell the fake that it should return for this user ID, it should return this name. And then we call user client.getName. And then we can assert the result. Okay, very similar for a failure case. Now we set up for failure, and then we run the getName, and we verify that we get the exception. Now that's the a bit problematic part, because we have some assumption that when the user is not found, there will be 404 HTTP status, but maybe the reality is that it's 200 status with an empty payload. We can't really be sure about it. So while we do get short and reliable feedback loop in this approach, we are not sure that our assumptions are correct. We don't test them versus the reality. Only when we'll go to production, we will see if it's correct or not. So if we don't fully understand the protocol or the schema, we might fail here. Also, sometimes the service have a complex state and interaction. So for example, you have a build server. So you tell it, build the version, and then you tell him, give me the last version. So there is some logic of incrementing the version, which it might be hard to implement. Another disadvantage of this method is that if there is a service provider that many consumers use, like it happens to me a lot because I'm providing infrastructure, so there are a lot of consumers. So now each one of them need to implement the test doubles for his tests. Right? And this is like kind of waste that each one of these teams should implement it. So to sum up this approach, our end-to-end works fine, but the integration is partially working. Because if our assumptions are correct, it will give us what we want. But if we are wrong, so we will know about it only in production. And we want to do better. We want a higher level of confidence. And this is where TestKits come to help us. Now, TestKits, in TestKit, we move the responsibility from the consumer of the service to the provider. Okay, so now the provider of the service is responsible to provide the test kit. And what is a test kit? It's actually a lightweight version of the real thing. Okay, so I'm, as a store developer, will get a test kit of users server, which we'll call it users test kit, and I know that it works as I expect. Let's have a look. So again, in our diagram, we replace this blue box with the user test kit. Let's have a look at the code. So our end-to-end is very similar to what we saw before, but now our TestKit provider give us something a bit more generic, and because he knows the domain, so he can provide this to us. So here we get users test builder. Okay, this will help me to build a user. And if I just need a user, I don't care about anything, I can just use it. It have defaults. Imagine that this user might have 50 fields inside. We don't want to fill all of them. By the way, in the implementation of the fake that we saw before, we need a reply that might have 50 fields inside. So here we say, okay, just give us this ID, give us this name, everything else put some default values or random values, and build it. So now we set up our test kit to have this user inside. The next part is exactly the same like it was before. And the assertion is also exactly the same. But now we know that we have something that does the work for us, and we didn't have to implement this. Let's have a look at the IT in the integration. The setup is very similar. The same setup for the test kit. Then we call getName. And then we assert that the name is what we expected. Okay, so the connection is the user ID and the name, and it works. Now, the not found case is a bit more interesting here. Because here now, we don't even need to set it up, right? We just try to get the name, and the test kit already know how to behave when there is no such user set up in the test kit. So it will work as expected. Okay, now we also know that the protocol is correct, and the schema is correct, and everything is correct because it was provided to us by the service provider. So how this test kit looks like? You can think about it like a library. It might have a start method with a port if it's HTTP. It might have a stop method. So you just do a new user's test kit and you start it. And you put the port that you configured in your application, the port of the user service server. It will have it will have the public APIs of the user's server, of course, but additional to that, it will have some helper methods. For example, in reality, to add a user, it might be a very complex procedure because you need to come and fill a lot of fields. Then you have an email with a link that you need to click on this link and confirm your account. But as a developer of a store, you don't want to know about all this complexity. You just want to have this method given a user. You can also update a user. Now, have a look. The update user doesn't get a user because some fields might be okay to update, some fields not. So, as a TestKit provider, this is my opportunity to let the other developers know what is legal and what is illegal to do. So now, let's see from the other side, from the side of the TestKit developers. So far, we saw how it looks from the side of the consumer, the store application. Now we'll have to see how it works from the side of the TestKit developers. Or I think like most of you will probably want to know, okay, now I want to build a test kit, what should I do? So first, I want to try to explain a bit better what is a test kit. So we have this bar here that the right side is, or the left side is test doubles, and the right side is the real thing. So test kits is somewhere in between, a bit more closer to the real thing. I'll explain what it have. So it must have the protocol and the schema. Okay, this is a must. And in addition, now we choose depends on the service, on the complexity of the service, of the needs, on how many users we have. We can put validations inside. So for example, it's an SMS service. So we validate the number. We expect some format for the number. So we can run the validation in the test kit, and then the users can give us an invalid number and see what errors they get as a result. We can put the logic, like the example I gave before with the build server that the increases the number, or you do some interaction with the service, so you expect something else to happen. When you do 3 calls to different APIs, each one affects the other. So you might want to include this logic inside the test kit. Playing with time. In some services, it's important to be able to play with time. So let's say I have a coupon service. So I create a coupon, and it expires after a week. I don't want my test to run for a week. So I will give some helper method to go 1 week forward with the time. Setup helpers, like we saw before with the given user. I don't want to go to create a user with the public APIs because it might be very complex. So the TestKit provider will give me an easier APIs in addition to the public APIs. Also setup for error cases. For example, I want to know how the system behaves when the database is down, when whatever happens. So I'm able to set up for error cases. And the last thing we might want to include is verification methods. Again, let's say we call an SMS service, and then we want to verify that it was called with a certain parameters. So now, another benefit that you get from it when you do this is that you're able to communicate with your consumers. When something changes, they know about it. And you need to think about it when you decide what parts to include. So for example, they have some assumptions. They write their test, everything works. But now you decide to change something. And when you change it, your test kit changes because it depends on your production code. And when your test kit changes, their tests run again. And now, if something breaks, they will know about it and you will know about it. And then you can decide if you did a breaking change or maybe they have a mistake. So, opposed to documentation, which gets stale, and you know what, even if it's not get stale, everyone knows that it gets stale, right? But even if it doesn't get stale, the consumer developers don't read it every new version of the documentation. So here, it's like a live contract of your service. It represents the real, what's really happening. And you can go even one step further. You can use it as a way to communicate with your consumers. So let's say you want to deprecate an API or break a contract. So you could change your code and deploy to production and then see if something breaks or not, right? An alternative is you could change the contract only in the test kit and not in your production, and then see if someone breaks. And then you decide if you include this code in your real code or not. Okay, this is a very powerful tool. And actually, you're like running your code under test. You can start with writing logs. Don't use this method anymore. And you can then throw an error. Another question is, what about next level dependencies? So our user service have a database, right? So when the store application runs the test and runs the user test kit, we don't want a database to run now, okay? So what do? We use integration contract test. Okay, there is a good blog post that I encourage everyone here to read anyway. But this test that defines the contract of stuff, and let's see examples. So in the user server, we work with MySQL, for example, and we have MySQL DAO. In our test kit, we don't want this MySQL, so we have in-memory DAO, an in-memory implementation of the DAO. And the integration contract test defines the contract that this DAO should comply. So actually, we run the same test suite against these two implementations, and we expect exactly the same results on each run. So when we run the tests and all the tests pass, we know that our in-memory implementation works exactly like the real MySQL implementation. And we take it even one step further. We do the same method we do in the integration contract test for our server and our test kit. So we define the contract that our server needs to comply. And then we make sure that our test kit complies to this contract. Meaning that when the store runs the test against the user test kit, they're sure that then when they will go to production, it will just work. Because they know that I'm doing this integration contract test for them. This is a very powerful and very important part of the test kit. So when you do this, your integration between teams becomes much easier. We almost don't have like this, that we find out about problems in production. You find your integration problems very early in the process. Of course, like in any talk, we need to talk about disadvantages. So, of course, it's more development, it's more work for the service provider. But like for the organization, I think it's a good thing because only one team does it instead of all the consumers. And another disadvantage is a build dependency on the implementation of the service. So your dependencies in the tests is bigger, and if you're doing continuous integration, continuous delivery, it might, like every change might run other builds. So just to wrap up, I think we got it, right? We have what we want. Our end-to-end works good. Our integration works good. We have really high confidence in what we are doing. We know that when we will go to production, it will just work. So just to sum up the approaches, there was the approach of don't doing test. So we agreed. I hope that everyone here that came to this talk doing tests. So you do want to do tests. The next approach of using an external environment, please try to avoid it unless it's a really extreme case. Sometimes you do need to do it. For example, if you're working with a third party and the protocol is very complex, so you might want to have like in the side something that tests it. The next approach of test doubles, it's a legit approach. Usually we start this way with a fake, and then the test kits is a smarter fake. So sometimes we start with the test doubles, and then when we see that service have a lot of usage, we provide a test kit. By the way, tomorrow there's going to be a talk by Talia about Petri, which is our experiment system at Wix. It's open source and it also have a test kit if you're interested. And I think that's all. Thank you very much. And take questions. Yes, Alon.
Hi. Hi. So thanks, first of all. This was really interesting. I'm wondering if you can elaborate a bit more about the disadvantages. Like things I could think about is it seems that you rely on all of your services to basically use the same stack. So I guess Java, Scala, whatever.
Yeah,
so
okay.
if you want to do like cross-language test kits, this becomes a problem. And also one more thing, like you were mentioning how when you update your test kit, it triggers CI of other, like all your consumers as well. So the more consumers you have, basically it slows down your provider's CI process or something like that?
Yes. So for the first question, of course, this approach that I showed here relies on that you're working on the same language. We didn't try to do it between languages, but it is possible. You need to provide an executable so it can run, and then the helper methods will be need to expose via some protocol that can speak between processes, like HTTP. So I never tried to do it, but you should be able to do it. Just provide executable and externalize these APIs. And about the second question, so yes, the way we work at Wix, so we don't have versions. We build against the latest version all the time. So yes, once you change an infrastructure thing, a lot of builds get triggered, and it affects the system. That's why I wrote it here. But think about the alternative. Like, you want to know if something if something breaks. So it's a price you need to pay, I guess.
Sorry. Okay, the question. So when you're talking about this test kit, frankly speaking, I didn't understand whether that is some specific product or that is just a abstract tool we're using. So
okay, it's not a product. It's an approach that we use at Wix.
Okay,
we provide, like, service providers, especially infrastructure services, provide test kits to other developers, and then they can use it to integrate much easier.
Okay, so as far as I understand, at the moment you're not using tools like Postman or something like that. You're trying to implement it from scratch by yourself within the code with your language of programming.
Yes.
Okay, so then second question. In reality, it's a rare case when your business workflow consists only from one request and one response. Usually that is a sequence of actions.
Right.
And at each of the steps, there is possible variations of the behavior. So when you're trying to mimic your real business scenario, you tend to implement almost the same implementation within your test kit as you have within your production code. So what is the strategy you have in place?
So the point
to avoid the situation when you just have copy paste of your implementation.
Yes. So I'm not copy pasting my implementation. Maybe that part was missing. So let's have a look here. This one. So I do use, maybe it's not the slide, but I try to use the same code, okay, as the production code. So I choose which parts are relevant. I just change the boundaries. So if you have hexagonal architecture, you just change the adapters. So instead of the MySQL DAO, I put in-memory DAO, but the logic, the business logic is the same. And this way, I ensure that it was the same. I'm not copy-pasting my code to the test kit, okay? If that wasn't clear. Did I answer your question, or?
No.
Okay.
Yeah, of course I understand that you're not copy-paste from production to test suite. That's clear, of course.
Okay.
But the number of variations you possibly have. For instance, you're talking about some shop, yeah? And you would like to test a scenario when I have 2 items and the third item I can buy with some coupon. I don't know. This is fiction, yeah? So that means that I have at least 2 scenarios here. One scenario when my third item without coupon and scenario when my third item with coupon, so I have some discount. So there is a 2 at least logic I need to implement, yeah? So within the test case,
you're talking about implementing a test kit for the store?
Yeah, how to implement
your scenario is like you want to implement a test kit for the store, right?
Yep, yeah. So this is this out process test, yeah, as you called it. So from this perspective, that means that within my test kit, which mimics the logic of.
So if you have some complex scenario and you want to get to a certain state, you can provide helper methods, like I said with the user. So to create a user, it takes a lot of steps. You need to give information, click on the confirmation link and whatever. And as a TestKit developers, you can just provide a helper method like give me user. So for what you said, you can provide TestKit, give me like with coupon, without coupon, whatever you want. So it will be easier to get to a certain state.
Okay, then just to get understanding of the scale of this problem, how many developers within your team?
My team, 5.
Rough. Okay, rough. And how many developers are responsible for supporting this test kit? Or that is not there is a specific developer, there is a team's responsibility.
No, the team's responsibility.
Okay. Can you give a rough estimate? What is the percentage of the work time you're spending for supporting this test?
I think that most of the time is to build it, and then it actually saves you time. But because before we had these test kits, developers every time came to a room and say, "Hey, I'm trying to integrate with your service. Doesn't work, help me." And now when they have this, they can just run it. I also provide something called sample app. It's like a sample application that uses this test kit, and they can have a look how it looks. They can implement it in their code, and they know that if it works, it will work in production. And it's much easier. It like saves a lot of time.
And sorry, too many questions from my side. Last question, once again. Why you have decided to implement everything by yourself, not using some tools? So, for instance, you can get a postman and you can record the sequence of actions from the server and then replay, and that would be the base for your test.
Few reasons. So one of them is that what your approach is like test fixtures. So you record something and then you have this fixture. So
at API level, yeah.
Yes. So, like you said, in complex scenarios, it might not work. When you change the code, you need to do this work again. And if you have 10 consumers, each one of them need to do it, right? So, like, there are a lot of disadvantages.
So you tried that approach and refused from it, or that is more theoretical?
No, we didn't try it
Okay.
because we found it that this one works for us.
Yeah. Thank you very
well.
much. Sorry for
If
too many
you want
questions.
to talk any more, you can find me later. More questions? Yeah, here.
Hi, thank you very much. It was interesting, and I have actually 2 questions. First one, so you mentioned that author of the toolkit can extend with some helpers, yeah?
Right.
But from my perspective, so if one service has a lot of consumers, maybe this author will get a lot of different requests, like, please, we need this kind of thing, we need this kind of thing, we need such ability to preset up everything. So, and usually it is priority, yeah? One team, another team, so our team requests some other team to extend. How you manage to do this, and is it really a case when each person will get what he or she wants from
Yes.
your
Okay.
from your
So
test kit?
the first part of my answer is that I'm trying to build APIs that they're extendable. So here I provide the test builders. So to build a user, I can start with the basic needs like just user ID, email, name, whatever, and then maybe I have a new request. So I need to activate and deactivate a user. So when it's extendable, it's easy to add here. And of course, it's like priorities thing. So if it takes time, there is another alternative that they can do a test double, and then they can choose if they can wait or do the test double. So, like if there is amount of work and you have less capacity, so of course.
Yeah, the toolkit won't get the highest priority, I think.
No, it will, because it depends like how many users have and how much they need it. So.
Yeah. Okay, thank you. And another question is when you have a case when one service depends on another service and your store, so like, T will depend on another one. Yeah, your big diagram.
Yeah, but so it's
and you reuse these toolkits. So, for example,
no. So something like this, right? The user server depends on the database.
Yeah, this is database, but I mean
about other services.
Several
yes,
toolkits.
so it's very similar. So usually I will not use the other test kit because then it will make a huge mess. what I will do a test double and do integration contract test between my test double and their test kit. Okay, so I know that my test kit behaves like my test double behaves like their test kit, and they work the same. And also I have this, so I know that I behave like I want. So.
So you do not reuse inside test kits.
No.
So, okay, thank you.
Hi, thank you. It was a quite interesting speech. I have such a question. For example, you tried to simulate the behavior on production and test it using the test kit. But what about the changes on production? You can have many hot fixes, change requests, and the production environments extended with new functionality, with fixes of bugs, and etc. Who is collecting all this information and who is responsible for putting all these changes to kit? Because if you have quite deviation between your test kit and the production behavior,
so it's exactly. Oh, sorry.
Yeah.
Okay.
So how you handle this issue, because it's quite difficult to maintain.
So it's exactly this slide, because I have a test, an integration contract test, that we define the contract that we expect from the user server, okay? And we run exactly the same tests, again the user server, and then exactly the same test run against the user test kit.
But could you please provide an example of integration contract? I understand that it could be some RAMs or something, but if it's quite huge application, what?
So we have our test.
It could be many contracts, and
yes,
there is always also a problem to handle that.
We defined our contract, for example, when there is a user and we expect to get something. When we do deactivate on the user and try to get, we try from this API, it should be returned, from this API not. So all these kind of tests that you do anyway for your user server, you need these tests anyway. So all you need to do is, like, let's say in Java, it's a base class and then 2 implementation tests that inherit it. One of them will have the user server and the other one the user's test kit, and then it verifies that they have the same behavior.
Okay, and the last question, do you have some separate people who are responsible for these contracts?
No, so it's the team's responsibility.
So all the teams are
Yes.
responsible. Okay, thank you.
Okay, thank you very much, guys. And we have some time, more time? No, so thank you. I'll be around here if anyone have more questions. And today and tomorrow, you can catch me around.